Good day, grade 11 chemistry students. Today, what we're learning about is a brand new concept called the mole, okay? It is very important. You may want to come back to this lesson, take some quick notes, watch it first, and then maybe write some notes. It will be fast. Our main learning goal today is to use the mole. We're doing something with quantities or amounts of things and chemical reactions, and we're going to focus on the quantities, and our most important quantity is something called the mole. We're going to use it to convert between number of particles and what we call atomic mass or molar mass. From now on, I'll refer that to as molar mass. Okay, so let's get started. Okay, so before we define what the mole is, what we're going to do is just do a quick activity. And our activity is to calculate how many donuts are in 12 dozen. Now, I want you to figure this out. And I know you're probably going to just think about it in your head, but I want you to use it using something we're going to call unit cancellation. And so what that means is you can use fractions and multiplication. You can't use division. You can use the division button on your calculator, but when you set up an equation here, you can't use division. So pause the video and see if you can figure out to calculate how many donuts are in 12 dozen. Okay, so to find the number of donuts, I'm going to use big N to represent number of things, and we have 12 dozen to start. This is what you should have thought of, and I hope you did. If you didn't, that's okay. What we're going to do is we're going to multiply by a fraction so we can sort of avoid the use of division, the division sign here anyways. So we're going to put, we have dozen here, so what we want to do is we want to cancel out those units. This is called unit cancellation, so I put dozen down here, and then I put donuts on the top. Now I'm going to put some numbers in here that are going to be equal to 1, or they're equal to the 1 in the sense that they're the same amount. So what numbers can fit in here? Well, we know that for every 1 dozen, there is 12 donuts. So we read this fraction sign, 12 donuts per 1 dozen. Does everybody understand that that's the same quantity? So in a sense, it's like equaling the same amount. So if you divide them, it's equal to 1. Let's take a look at with unit cancellation here. What we do is these units up here will always cancel with the units on the bottom, and you get 144 when you multiply 12 times 12 times 12 divided by 1 is 144, and our units here cancel, and our units that we get are donuts. So that's how you calculate that. Let's see if we can try another one really quickly. So let's look at this next question. It says, how many dozen are in 156 donuts? Well, to answer that question, what we do is we take our number 156 donuts, and we're going to multiply by a fraction. We want to get rid of the units donuts, so we put them on the bottom, and it says how many dozen, so we want to go to dozen on the top. What we do is we have to put numbers in here that make sense, that are equal to each other. We have to put a ratio in there that makes sense. Well, we know for every 1 dozen there is 12 donuts. So this will give us the amount of dozen that we have here. Okay, so when we calculate this out, and 156 times 1 is 156 divided by 12 is 13. So if we look at our units, the units that are on top and on the bottom always cancel, and we got answers. Now, what does this have to do with the mole? Well, it actually has a lot to do with the mole. If this was easy for you, then a mole is going to be easy. We just have to do some calculator tricks. Let's take a look at. So a mole is a quantity just like a dozen is. 1 dozen is equal to 12, 1 gross is equal to 144, and 1 pair is equal to 2. Well, 1 mole is actually equal to this, 6.022 times 10 to the 23 things, okay? So all these things represent, you can have a dozen of anything. I have a dozen cars, a dozen shoes, a dozen anything, a dozen things. Well, I can have a mole of anything as well, okay? And a mole is a massive number, and we're going to talk about why in class it's such a massive number, but we're going to treat it exactly the same as we would in terms of our calculations. The calculations we just did, we're going to show you exactly how to do them with a mole. Now, the only trick about this is when we put this in our calculator, what we do is you pull out your calculator now, you press 6.022, and then what you do is you find your EXP button. You don't put times 10 in, you put 6.022 EXP or EE on your calculator and then hit equals 23. That's how we're going to input that number into our calculator. Okay, so quickly just pause this and you're going to actually write this down. This is the actual definition of a mole, okay? And a mole is actually equal to 12 grams of carbon. In our next video, we'll discuss the significance of this, but it's an experimentally derived value, 6.022 times 10 to the 23. It's comes from experiments, and it's an easy way for us to measure things. And why do we use a mole, or why do we use a dozen in the first place? Or, you know, when you go to order donuts from Tim Hortons? Well, the answer is because there's so many things, okay? There's so many donuts. You're not going to go into Tim Hortons and say, hey, man, I want 512 donuts. It doesn't make any sense. They're going to look at you weird. They want to know how many dozen you have to order because that's an easier number to work with. It's a smaller number. Now take a look at the tip of your pencil right now. The tip of your pencil actually contains like a quadrillion atoms. So that's not a very easy number to work with, but it might only contain something like 3 or 4 moles. So it's a smaller number. By using a mole, it makes numbers small. So this is the equation that we use, and little n represents moles, okay? And the units for moles are mol, okay? Now we have big N, and big N represents the number of things, okay? And then finally we have Na, and that stands for Avogadro's number. And Avogadro was the Italian scientist who came up with this value through experimentation, and the value is 6.02 times 10 to the 23 things, okay? Now, normally when we're talking about things, we're talking about molecules or atoms, okay? And so we are also talking about something called formula units, which I will make sure you understand as well. So this is sort of our, we'll call it our dummy triangle. If you want to find n, you cover it up, and n is equal to n divided by Na. Or if you want to find this guy, you cover up these two, and Na is equal to n divided by Na. Now, so let's continue. So we have one question here. How many formula units are in 1.6 moles of salt? So to calculate this, what you need to do is you need to write down your triangle, okay? N equals N over Na. And let's check off what we have in this equation. We have moles, okay? So we can check off that we have that. We want to find how many formula units we have, and that is represented by the number of things. So we want to find this. So the question is, do I know Na? Well, yes, we do. Na is a constant, and you're always going to remember this number. So let's take a look at this. We want to cover up n, and what it says is it says n equals n times Na. So let's just fill in our numbers, and let's calculate. So if we take a look up here, you know I've written moles, M-O-L-E-S. Well, whenever we write it as a unit, we write it as M-O-L. Sorry, just M-O-L. Don't ask me why, that's how we do it. Now it says that we're going to multiply little n times Na. So we basically just multiply it out, okay? So what happens is we just take our number and put it up here. Now the reason why I'm putting over the fractions is because this is exactly like the donuts question. Right now we have mole here, so we want to put mole on the bottom, and that means that's going to cancel out. And we want to write formula units on the top, okay? So I just write it as F units, okay? That's not a dirty word. That stands for formula units. Now, this whole thing, what number do we put it over top of it? How many formula units are there in a mole? Well, the answer is there is 1 mole is equal to this. This is the same amount. Now, when we put it in our calculator, again, do this in your calculator with me. Honestly, do it. Megan, please do it. It's 1.6 times 6.022 times 10 to the 23. So what you do is you put this number in first, put 6.022 times, and then put, instead of times, put in EXP here, and then hit 23. Okay, so EXP button 23 equals times 1.6. If you did it correctly, you should get this. So if we take a look, we have 9.6 times 10 to the 23 formula units. So if you have 1.6 moles, that means we're going to have more than a mole. 1 mole is 6.022 times 10 to the 23. We're going to have 1.6 times as much as that. Okay, so we have 9.6 times 10 to the 23 formula units. Next question we're going to ask is how many moles are in 3.55 times 10 to the 23 molecules of water? Well, we're trying to find moles, so that's a little n. And it's giving us the amount of things, that's big N, so we've got that, check. Let's look at our dummy triangle. Let's check off with what we want to find. We want to find little n. This is big N up here. I know it doesn't look like it. So we have that check. And obviously we have Avogadro's number. So to find this, what we do is we cover it up, and n equals n divided by na. So let's fill in our values. Okay, so in this case, I have just filled in my values here. And if you look, you're kind of be struggling. Well, what number do I put next to Na? This is Avogadro's number, 6.022 times 10 to the 23. Well, the answer is we want to put in here molecules, and I'll explain why in a moment. And we want to put it over 1 mole. I'll explain. Whenever you do Na, you always put it over 1 mole. And the reason is it's going to allow us to do unit cancellation. Now, these units will cancel out and you'll get moles. Let me show you this another way. Remember, when you have a whole number divided by a fraction, we multiply by the reciprocal. So what we have here is I've just flipped this value and we've multiplied it. And if you take a look, it looks exactly like our previous types of questions. Now all we have to do is in our calculator, what I would do is try this with me. It's a lot of calculator work here. Always remember, instead of times 10, put in EXP or EE. So in your calculator, write 3.55 EXP 22 divided by 6.022 EXP 23. And the answer you should get is the following. So the answer you should get is, again, sorry for repeating myself, 0.0590 moles. And that is it. That's all there is to it. I'm going to put up one problem. I'd like you to try and attempt it for me tomorrow. Recall, if you didn't get the exact same number in your calculator, it's because I rounded to 3 significant digits because I had 3 going in. This is a constant, doesn't count, so I should have 3 coming out, 0.0590 moles. So that's a lot less than a mole. Well, take a look. It is actually a lot less because we are starting with 1 less times 10 value compared to Avogadro's number. Try this problem and bring it tomorrow to class. So how many molecules are in 2 moles of water? Remember, when you write the units, you write it as MOL. Okay, when you actually put it into your equation, this is your triangle here. Check off what you want to find and check off what you have and go ahead and solve it. Bring it to class tomorrow. Hope you enjoyed your evening. See you tomorrow.
Well, it's a world that man can eat at all. When things are big, that should be small. Who can tell what made